Hello everyone, this is Niranjan Kane studying in Sri Venkateswara College of Engineering. So I am here to explain the topic called Insertion Sort and Topological Sort in the subject named Analysis on Design of Algorithms. So let's jump into the topic Insertion Sorting and Topological Sorting. So here is Insertion Sort Overview. Insertion sort is a simple sorting algorithm that builds the final sorted array one item at a time. It is efficient for small datasets or nearly sorted datasets. The algorithm is in place and stable. So we move on to insertion sort steps. Start with the second element and compare it with the first element. So this is the first step. We take as the first element as key, which is 5, and now it will swap with the number 9. So by taking 9 as a bigger than 5, so we swap it to first element. So the second step goes like insert the element into the current position in sorted array. Repeat the process for each element in the array until unless it gets all the elements in order of ascending. The iteration continues. So the algorithm of insertion sort sorts a given array by insertion sorts. The input is like an array of A of 0 to n minus 1 of an n orderable elements. So we get an output like array A 0 to n minus 1 sorted in non-decreasing order, which is also called as ascending order. So the algorithm is like for I to 1 to n minus 1 p is equals to a of y and j is equals to I minus 1, while j is greater than 0 and a of j is greater than v, to a of j plus 1 is equals to a of j and j is equals to j minus 1 and a of j plus 1 is equals to v. So this is the algorithm used for solving the entire elements to arrange in order of ascending order. Insertion sort efficiency. Time complexity of 0 O of n to the power 2 is the worst case scenario. Space complexity of 0 1 as it requires only constant amount of additional memory. So it is efficient for small datasets and nearly sorted datasets. As you can see in the example, another example where the elements are sorted in ascending order. So one more example of insertion sort. Consider an array of 5, 2, 4, 6, 1 and 3. After each iteration, the elements goes like 2, 5, 4, 6, 1, 3, 2, 5, 4, 6, 1, 3. So as you can see in the diagram, each element is went an integration and brought to its ascending order. So we will get a final sorted array as 1, 2, 3, 4, 5, 6. Applications of insertion sort. It is useful for small datasets and nearly sorted arrays. Can be used in scenarios where the elements are added sequentially, often used as building block in more complex sorted algorithms. So the challenge faced by insertion sort. Inefficient for large datasets due to its quadratic time complexity. So which means it cannot be applied for large datasets as it consumes more time and it is more complexable. not suitable for datasets with random order of elements. So the input should be given by us to get the insertion sort. The random function value will not be taken as its consideration. Limited applicability compared to more advanced sorting algorithms. So the application of this algorithm is limited. The second sorting is topological sorting. So overview of topological sorting is a linear ordering of vertices in a directed acyclic graph, which is also called DAG. It is used to schedule tasks, dependencies, and optimizes order of execution. So there are two types of topological sorts: DFS based topological sort, and one more is source removal topological sorting. So first we move on to DFS based topological sorting. So it performs a depth first search on the graph. It adds the vertices to the stack in reverse order of finishing time and pop the element from the stack to get the topological order. Requires a recursive function to visit all the vertices, works efficiently for large graphs with multiple connected opponents. Time complexity of O of V plus E, where V is the number of vertices and E is the number of edges. As you can see in the diagram, where the topological sorting of a graph is done. So firstly, the element are arranged, inserted to the stack and arranged in topological order using DFS based algorithm. DFS based topological sorting. As you can see in the diagram, firstly we consider as C1 where it moves to the C3. So second element is C3 and then it moves to C4 and so on it moves to C5. Again C2 is considered for last element because it moves to the C3. So we arrange the dead end elements like C5, C4, C3, C2 and we get the topological sorted list as C2 to C3, C1 to C3 and C3 to C4 and C4 to C5 and so on C3 to C5. So we move on to source removal algorithm. As the diagram suggests, it is an easy algorithm where the same example which I took for DFS algorithm, I took for source removal algorithm also. So here in this case, we delete the C1 first in the first step, then the next element which is taken as C2 and delete it to next the element goes like C3 and delete the C3 element. Therefore, next element is C4 which is deleted. Finally, D5. So the solution will be obtained like C1, C2, C3 and C4 and C5. So the applications of topological sorting. Task scheduling in project management. Build systems to determine the order of completion. Dependency resolution in software and package management. So the challenges faced by topological sorting is limited to direct acyclic graph, requires additional calculations for integers or DFS traversal, not applicable to graphs with cycle. So we finally conclude that Insertion sort and topological sorting are fundamental algorithms in computer science. Each algorithm has its strength and weakness based on dataset and graph structure. Understanding these algorithms can enhance problem solving skills in various domains. So that's all for today, guys. Thank you.